morning. This is Dr. S. Subalakshmi, an assistant professor in the Department of Mathematics, SNS College of Technology. Now we have gathered here to discuss about the design thinking based lecture video on Gauss Divergence Theorem. So actually we have learned the statement of Gauss Divergence Theorem and a problem which comes under the verification process of Gauss Divergence Theorem. Now we are looking on to the design thinking based approach on the Gauss Divergence Theorem. We have our students to here explain the concepts and to discuss the concept very well. First slide. So here this is the empathizing stage of design thinking concept. Firstly we are going to imagine that the environmental engineers studying air pollution inside a closed industrial building. So that is exactly what we are about to imagine. We are just going to imagine a closed building wherein some air pollution is happening there. Then what do you observe there?
There is some sort of polluted air is coming out from the industry.
Okay. So there will be some sort of polluted air coming outside the industrial room. So that is what we observe there. And what is the total outward flow of air from the building? How can you analyze that?
We can find by using some mathematical tools.
Yes, in using some mathematical tools, we can find this total outward flow from inside the building towards outside the building. So we will go on to the further discussion on the same topic here. The second slide. So this is the definition stage. This is the defined stage of design thinking concept. In the problem, what is the problem definition actually? We need to calculate the total outward flow of polluted air across the surface of a closed room. This is what we have as the empathizing part, and that is the problem definition here. In that we have a Lake equation. What is the equation? So how will you calculate the air velocity field inside the room? How it can be calculated?
We can calculate it using unit normal vectors.
We can calculate it using unit normal vectors. So what are the unit normal vectors along all the three axes?
Along x-axis it is I vector, along y-axis it is j vector, along z-axis it is k vector.
Yes, along x-axis it is I vector, along y-axis it is j vector, and along z-axis it is k vector. And combining all the three, we have the vector function as f vector here. So f vector is equal to xi vector plus yj vector plus zk vector. And our goal is to find the total flux of air leaving the room using an efficient mathematical method. So we are going to find an efficient mathematical method to find the flux here. So next slide. So this is the ideation stage of our design thinking concept. What are the possible approaches you can find, Ma?
Ma'am, these are the possible approaches. As we see here, compute flux through every surface separately, use surface integrals, apply the Gauss Divergence Theorem.
So as we have discussed here, these are the three major points to be noted as the possible approaches in the ideation stage. What do you know about all these three things in which you knew already?
Ma'am, I know Gauss Divergence Theorem, which is easy and efficient to solve.
Yes, actually it is very much easier to solve these kind of problems. We knew already about the Gauss Divergence Theorem statements and problems as well. So here we choose the Gauss Divergence Theorem because it converts a surface integral into the volume integral, making the calculation very easier. Next slide. And as you said, you knew Gauss Divergence Theorem. What is the statement of it?
Some statement is double integral over S is equal to triple integral over V.
Yes. Actually, we are interlinking the area concept and the volume concept in Gauss Divergence Theorem, which is double integral over S is equal to triple integral over V. On the LHS, we have f vector dot n cap ds, and the RHS, we have del dot f vector into dv. So we have to find both the sides. What do you mean here? Actual combination of the problem here is the total outward flux through a closed surface is nothing but the total divergence inside the volume of the actual surface. So this is what we infer from as a result from the Gauss Divergence Theorem. Next slide. So this is the prototyping concept. What is the vector field given here? It is we have already discussed that f vector is equal to xi vector plus yj vector plus zk vector. And we have to compute the divergence. What is the divergence, Ma?
Del dot f vector is the divergence of that vector. It can be calculated using the formula of f vector.
Yes, we can be calculated using the formula of f vector, del dot f vector. What is del actually?
This is dou by dou x of I vector plus dou by dou y of j vector plus dou by dou z of k vector.
Yes, we have to make a dot product for del and f vector for the given f vector. We have got the f vector as well. So on dot producting it, we have dou x by dou x plus dou y by dou y plus dou z by dou z. On calculating it, you have the value to be 3. So what is del dot f vector here? It is 3 here. So we have found the prototype stage of design thinking concept. Next slide. Now we apply the Gauss Divergence Theorem here. What is the value actually we found earlier? 3 actually. So the triple integral over V is 3 into V. So if the building is a cube of size 2 units, what will be the volume here? Actually it will be on the cube, it will be A cube, which is 8 cubic units will be there. So since it is a cube, we are multiplying the triple integral over the volume by 8. So that the flux will be 3 into 8, which is 24. 24 units you have found as the total flux here. Next slide. This is the testing stage of our design thinking concept. In interpretation, what is the total outward airflow from the building? What have we found actually in the previous slide?
Triple integral over E is equal to 24 units.
Yes, triple integral over V is equal to 24 units is the thing we have found. That is actually the total outward airflow from the building. So this have been interpreted as the total outward flow from the Gauss Divergence Theorem. And what is this conforming mark?
Air is continuously flowing outward. Divergence theorem simplifies the calculation. Instead of computing many surface integrals, we use one volume integral.
Yes. So actually, we have already noted that the air is continuously flowing outward from the inside of the building, and the divergence theorem can be applied to simplify the calculations well. Instead of calculating the area, we can calculate the volume here in a much easier way. And instead of computing many surface integrals on the surfaces of the cube, we can simplify it using a single volume integral here. This is what we have confirming with the help of our Gauss Divergence Theorem. Next. So conclusion. Can anyone of you read it?
We understood a real-world pollution monitoring problem, defined the airflow measurement challenge, selected the Gauss Divergence Theorem, built a mathematical model, verified the result using volume integration.
So these are the steps we have implemented in our design thinking concept to give a certified mathematical approach using design thinking for our Gauss Divergence Theorem. Hope this video have a clear-cut view on Gauss Divergence Theorem with the design thinking concept. Thank you all.